Unit 7.3, trigonomic ratios. All right, as we just talked about, anytime we have a right triangle, there is a ratio between any two sides of that right triangle. So we have names for these ratios. This is sine, cosine, and tangent. Okay, so sine is the ratio of the leg opposite the angle to the hypotenuse. So what I'm talking about is if we have the sine of A, okay, we're talking about the side that's opposite A, which would be lowercase a over the hypotenuse C. All right, so the sine equals the opposite. And when we talk about, we're talking about the side. So it's the opposite side over the hypotenuse. And we have to understand the hypotenuse is always the long side opposite the right angle, correct? Okay, so sine is always considered opposite over hypotenuse. So like I said, the sine of A would be, and I should say the sine of angle A is side A over C. So if you look over here, sine A, sine of angle A is equal to the ratio of A over C. Opposite over hypotenuse. Does that make sense? Okay. Now the sine of B, here's angle B. So what side is opposite angle B? Well, in this case, it's lowercase b, and the hypotenuse is still C. So the sine of capital B, or angle B, is B over C. Okay? That's sine, opposite over hypotenuse. And we say opposite side over the hypotenuse. Okay, cosine. Okay, we say cosine, but we abbreviate it COS, but don't say cos or cos or whatever. It's cosine. Cosine is the ratio of the leg adjacent to the angle to the hypotenuse. What we mean is next to. Adjacent means next to. Okay, so we'll write adjacent over hypotenuse. So cosine is equal to adjacent side over the hypotenuse. So let's go back up here. The cosine of A, in this case, the cosine of angle A is the adjacent side over the hypotenuse, or B over C. So cosine of angle A equals B over C. Okay. Now, when you talk about these things, how do we know it? How do we know the adjacent side is B and not C? Because C is always the hypotenuse, right? The side opposite the right angle. All right. What is the cosine of B? Remember, cosine means adjacent over hypotenuse. So here's angle B. So the cosine of angle B would be A over C. Okay. Now tangent. Tangent is opposite over adjacent. It's the first one that doesn't involve the hypotenuse. So tangent is opposite side over the adjacent side. So again, if we want the tangent of angle A right here would be the opposite over the adjacent. Or in this case, side A over side B. So we'll put A over B. All right. Now, we want the tangent of angle B. The tangent of angle B is opposite over adjacent, or in this case, B over C. I'm sorry, B over A. And you can see how these guys are reciprocals of each other, aren't they? All of these guys are kind of connected, you'll see in a bit. All right, we're not going to worry about this one right now. We're just going to move on and we're going to practice some of these ratios. If you can walk away understanding the ratios today and having those memorized, you're in really good shape. So we want to find the sine of A. I'm going to do these with you. Remember, sine is, let's go back up here, Sine is opposite over hypotenuse. So see if I can leave those in there. Okay. So what is the sine of A? What's opposite A? A over B in this case. So the sine of A is side A over side B. Okay. And what is the cosine of A? The cosine of A, remember, cosine is adjacent over hypotenuse. So adjacent would be C over B. That's a C. I didn't make that very clear. And finally, the tangent of A. Well, let's check. Tangent is opposite over adjacent. So what side's opposite angle A? A. What side is adjacent to A, angle A? C. Okay? All right, so I'm going to give you about 30 seconds to try and name sine, cosine, and tangent of angle C. Okay, so the sine of C, remember sine is opposite over hypotenuse. So here's angle C, so opposite is C over B. The cosine of angle C, remember cosine is adjacent over hypotenuse. So the side that is adjacent to angle C is A, and the hypotenuse is still B over here. So it'll be A over B. And then tangent of C, remember tangent is opposite over hypotenuse. So that would be opposite over adjacent. So it would be C over A. Okay, a couple things to recognize is that the sine of A is equal to the cosine of C, isn't it? And the cosine of A is equal to the sine of C. And that tangent A is the reciprocal of tangent C. And we'll talk more about that as we go on. All right, so let's put these ratios into practice. All right, so you'll notice we have one of the angles. We know one of the angles, and we have two of the sides. So the trick here is to pick the correct ratio, whether we should use sine, cosine, or tangent. So what I do is I find the angle that I'm referring to. We call this our reference angle. And I say, well, let's see, what do I know? I know opposite and I know adjacent. And I like to get in the habit of drawing those little arrows. So which one of our trig functions involves opposite and adjacent? And hopefully you see it's tangent, right? So what I'm going to take my reference angle and I'm going to say the tangent of 41 degrees equals the opposite over the adjacent, or x over 32. Now once I've set up my ratio, I'm just going to cross multiply. Is there any questions how I set that up before I go on? Okay, so the tangent of 41 equals opposite over adjacent. Opposite over adjacent. So now I just got to go to my cross multiplying. So 1 times x is x. 32 times the tangent of 41, we just write it as 32 times the tangent of 41 degrees. And this is where having one of these calculators really comes in handy. Now, all we have to do is, you'll notice x equals 32 times, and you'll see my three trig functions here, sine, cosine, and tangent. Well, today or this time we're using tangent 41. Enter. And I get 27.81. We'll always round off to the nearest tenth, so it's 27.8. So x equals 27.8. Okay? How do we do that? All right, let's go on and do this one. So here's my reference angle. You always find your reference angle. And what do I know? Well, I know the hypotenuse and I know the adjacent side. So it looks like adjacent over hypotenuse. Which one of our trig functions is that? Cosine, that's right. Adjacent over hypotenuse. Okay, so I set it up this way. First, my reference angle. I'm going to use cosine. So cosine of 21 degrees equals adjacent over hypotenuse, or x over 26. Any questions on how I set up that ratio? It's really a proportion because we're going to put it over 1. And then we simply cross multiply. First the variable. 1 times x is x. 26 times the cosine of 21, we simply write, I put my 26 in parentheses, cosine of 21. And now we simply take our calculator and we simply go, and make sure you guys can see it, 21 times cosine this time, cosine, oops, no, wait, it's not 21, it's 26, isn't it? 26 times cosine 21, enter, 24.27, so we'll call it 24.2, or excuse me, 24.3. Okay. How are we doing so far? Good? All right, let's turn it over. All right. So now we're back to identifying some ratios, which is really important. So before we do that, let's go down to the bottom. I want to teach you a little way that we've learned over the years. So if you remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And sine, or excuse me, tangent is opposite over adjacent. And what we spell there is so, ka, toa. Does everybody see how I came up with SOHCAHTOA? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we take all those letters and we write SOHCAHTOA. So that's a little mnemonic device to help you remember. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. Okay? I always do a little competition in each of my classes for extra credit. I pick one or two of the best mnemonic devices